Hello, my lovely friend. Today I come to you with a new challenging geometry problem. Are you ready to do this together? So let's get started. First of all, try to pause the video and think about it. Three, two, one. Okay. Here says find the shaded area. The shaded area is this purple circle. So let me put center of this purple circle, and the only information that question gave us is the length of this square. We see for each side of this square, two semicircles cover each side and lie on each side. So if the length of each side is 4, the length of each semicircle, that means diameter of each semicircle would be 2, because as I said, two semicircles exactly cover one side. So the diameter would be 2, and we know diameter equals twice the radius. So the radius of each semicircle would be 1. Great job. I find the radius of this semicircle. What we are gonna find? We are gonna find the shaded area. The shaded area here is circle. To find the area of circle, I need to know the radius of this circle. So I am gonna find the radius of this circle. If I draw a perpendicular line from the center of this circle to the border of this square here, exactly here, we will see this length would be the half of the length side of the square. So this length would be 2. I write this length would be 2. From the center to the border of this square. And I said this side is a perpendicular line. Now I will go from the center. We see this purple circle and this semicircle meet each other at this point. So from the center of this semicircle to this border would be 1. As I found it here, the radius of semicircle is 1. And then from here to the center of the purple circle would be the radius of the purple circle that I don't know the value of it. So I put R here. And again, from the center of this semicircle to this line would be 1, the radius of this semicircle. If you look here, let me label O, A, B. OAB is a triangle. Exactly, I create a triangle, right angle triangle here. So if I create right angle triangle, I can use Pythagoras theorem. So I try to use Pythagoras theorem. Pythagoras theorem says the hypotenuse to the power of 2. Let me write hypotenuse to the power of 2 equals the perpendicular line to the power of 2 plus base to the power of 2. Okay, what's hypotenuse here? It's r plus 1, OB. OB is r plus 1 to the power of 2. So what's perpendicular line, which is 2 to the power of 2? And base is 1. 1 to the power of 2 gives me 1. Okay, so I have r plus 1 to the power of 2 equals 2 to the power of 2 gives me 4. 4 plus 1 gives me 5. I take a root from both sides, and we should know when I am talking about sides, lengths, in geometry, I never consider the negative sign when I take a root. So I only consider the positive sign. So r plus 1, I take a root. I have r plus 1 equals square root of 5. I bring 1 to the right side, so r equals a square root of 5 minus 1. That's it. I found r. The value of r is square root of 5 minus 1. If I consider it, uh, square root of 5 would be almost 2.3 and 236, 236, 236, and minus 1 is approximately 1.236. Okay, I find r. I will go to find the area of this circle. We know the area of this circle would be pi r squared. And the value of pi is 3, almost 3.14 times. What's my r? Let me first write the formula. You have the formula here. I said the formula of the circle would be pi r squared. And I substitute the value pi. I said I put 3.14 times, what's my r here? 1.236, so 1.236 to the power of 2. This amount, when I write this amount to the power of 2, gives me almost 1.5 and 8. Okay, and then when I multiply these two digits, 3.14 and 1.58, the area of this purple circle is approximately 4.8. So the area of this purple circle is 4.8. We are done. I hope you really enjoyed. If you enjoyed, subscribe, share with your friends, and stay tuned. I will see you in the next new problem. Bye bye for now.